Hello, today in this video we are going to learn about the scaling procedures of time histogram motions in ETABS. So for that, let me go to define. Here we see the function tab, go to function. First of all, before uploading the time history, we have to upload or we have to define the target response spectrum. So here is the response spectrum tab. If we click here, we see that the response spectra for different codes, for example, AC710, IS, Mexican, etc. But if we have to upload the code which are not in this list, there is an option we have to choose from file option and add new function. So this form appears in which we can give the function name. In the function there is a function damping ratio which is 5%, and values are the frequency versus value and the period versus that acceleration value, and we can browse the function file from here and we will see the graph, and we have the option to view file. So here we can upload or we can browse the CSV file or text file which can be comma separated or space separated as well. So for now I'll upload this type of file. Let me go to my window. So we see the file of NVC site spectra. Let me click this one. Here we see the space separated file with no any header lines to skip. The first column is time period, and this one is the acceleration value, spectral acceleration in the form of G unit. Okay, so this file I'm going to upload, and this one is spectral shape factor with the same time value and the spectral shape factor. This is spectral shape factor is converted into the elastic site spectra for solid type C and D as well. So I'll go to again in ETABS, define function response spectrum, go to add from file, add new function, then I will browse, then let me select NVC response spectrum for solid type C. Here we see the response spectrum for solid type C, which is the peak plateau in 1 second, and the value is 0.875 and decreasing accordingly. So I'll give the name NVC. Sorry, so we'll see, and the damping ratio is 0.05. The values are period versus the acceleration value, and header lines to skip is 0 because there are no any text file or anything else above the data file. So we can view the file here. The file can be viewed in Notepad as well, and convert to user defined. I'll click this tab or this button because if we click this one, and if the ETABS file have to be moved in another PC or another place, this uploaded file will remain like this. But if we forget to click the convert to user defined, and this uploaded file, the source file will be deleted and will not able to obtain or to show this spectrum. Okay, so it is better to convert to user defined. So let me click OK. So we have completed the first step because we have to assign or define the target response spectrum in which we have uploaded the NBC 1052020 soils C type spectrum. So let me click again OK, and again go to define functions. Here we see the time history functions. Here by default we see the ramp th and unified th. If we see this file, these are certain values, and we see the sine function as well. Add new sine function. We see the sine function here. There are different functions, cosine functions as well. So this one is the cosine function, and here we see match to response spectrum, use a periodic triangular, and there is the option to upload from file as well, the time histogram motions. Okay, here if we select match to response spectrum and add new function, we will see the form of time history match to response spectrum, the function name, and we have the two methods to do matching. The first one is to matching in frequency domain, and second one is to matching in time domain. So after that, we see the target response spectrum. We just have defined for NVC type C, and there is a program default in which program default response spectrum is as for ASC 710. Okay, for site class C and long transition period of 8 seconds. So I will not use this one. We will use the uploaded NVC type C. And reference acceleration time history. Here is a program default. In program default, we see the El Centro earthquake. Okay, this one is the El Centro earthquake. But before that, we have to we can also define this or upload this time history ground motions. So before going to matching, let me upload the time history ground motion. So for that, let me go to from file, then add new function. Similarly, we can see the time history function definition from file form, in which we can browse the file, we can give the value of time and function value, equal intervals, header lines to escape, character, etc., and display the function. So let me go to first. So here, if we see the time histogram motions, which I have downloaded from Fear in GA records. So we will make the separate video how to download the time histogram motions from peer database. So here we see the time histogram motions which are downloaded, and we see the name is RSN334 Kulinga. Then at last we see 000 and we see 90, 90, 90 and up. It means the first three are the time histogram motion for acceleration, displacement and velocity for x-axis or 0 degree, 0 axis or east to west direction, and second one is for another orthogonal direction for indicating for as 90 degree. The same three file acceleration, AT2 mean acceleration, DT2 displacement, and B is velocity. Similarly, we see for vertical earthquake, same. If we download the data ground motion data from the source or peer in NGA records, we can download 9 ground motion data for one earthquake. The first one is east to west direction, the second one is north south, and the vertical earthquake. So for now, let me upload the acceleration file for this 0 degree or 90 degree. Okay, so for now, again let me go to ETABS, define functions time history. So let me go to select from file, add new functions, then browse. So let me go to desktop, png unscale, go to all files. Let me select the first one, 82 file. Okay, here we see the different format because we have to change the value accordingly, which have presented in the text file. Okay, so again, okay, I will see the text file first. Okay, so let me click again. So let me click the file of text file. Here we see that FearNG strong motion database record for Kulinga earthquake noted in 1983 in the Parkville Station fault zone 1, and these are the acceleration time histories of 0 in the unit of G. Okay, so the number of points considered are 5999 and dt, the time interval is 0.1 second, and these 5 columns are the acceleration value. Okay, so here are the 5 column acceleration value and number of lines to skip, header lines to skip, 1 2 3 4, and the time interval of 0.01 second. Okay, so let me again go to ETABS. After getting this information, then we can easily upload the file. So let me go to from file, add new functions, then browse, go to rsn that one. First of all, equal interval of, we can say 0.01. We have header lines to skip is 4. Okay, then the number of points to skip per line is, I think it's 5. Okay, there are 5 acceleration value. Okay, yeah, this one is the correct way of defining the or assigning or uploading the time histogram motion from the data which have been downloaded from PRNG records, and we can upload the file in the form of CSV also, and in the other format of text file also. Acceleration only files, time and functions value, acceleration time and acceleration pairs, uh, in other different formats which are compatible to this application. Okay, so we can view the file from here, the same file which we have just seen in the form of text file. Okay, so again, don't forget to convert this to user defined. So let me click to user defined, and it will take few moments. Okay, so this one is the name which automatically transferred from that text file, and let me click OK. And this is uploaded, or this is defined in this form, so you can delete this function as well. Okay, so let me click OK. Then again, let me go to define functions time history. Then only after adding this ground motion here, we can go to match to response spectrum, go to add new function. Okay, then here I can give any name, matched time history. So we'll select either spectral matching in time domain or frequency domain, and I advise to check in both domain because we have interest that the changed or the scaled earthquake should be similar in frequency content. So we have to try the both options. For now, I'll select the matching in time domain. So here is the target response spectrum tab. I'll say NBC soil type C, in which we see the target spectrum and reference acceleration time history. It is just I have uploaded. We see the reference acceleration time history. So the response spectrum acceleration unit is in the form of G, and the time history acceleration unit is also in the form of G. We can choose the appropriate unit, because if the unit are different, we will not get the accurate data or accurate matching. So be sure about the units. Okay, so here we see the this button gives the user defined. Now we have user defined. If here is the, if we select program default, we will see the default spectra of ASC10, and we'll see the default time history of L centroground motions. Okay, so this one is the reference or target response spectrum and reference time histogram motions. And we see here the set matching parameters. We can see either in the defined frequency range or program determined frequency range. Okay, this one is the frequency range. Let me click OK. So we see the plot of response spectrum in different format, log graph, but now we see the x linear and y also linear. Okay, this one is the linear plot, and response spectrum options, and these two options are not active now. So let me select first the match time history. Okay, after setting the matching parameters, it will take some time. Let me see. Yeah, we see the match time history as well as reference time history and spectral or target spectrum. Okay, so this blue line indicates the response spectrum of that reference acceleration time history, and the red line indicates the matched response spectrum. It means which I have already matched. And here we see the gray line. It is a target response spectrum and it is matching very closely. So if we see the plot reference time history, this one is the reference time history, and this one is the plot of match time history. And if we click this button, plot both the time histories, okay, the match and reference time history. So here, yeah, another option we see response spectrum plot function. We see the plot reference time history. We see the reference time history here as well as the target response spectrum, and plus matched one. It is nearly matched in high degree of accuracy. And if we click this one, we see the both matched reference and the target response spectrum. Okay, so here we see similarly the time history function. Then we see the plot match time history. It means it is already scaled. And if we see the frequency content of both match time history and reference time history, the frequency content, I think there is little deviation of frequency content. So be careful about the frequency content while doing the nonlinear analysis and during the scaling procedure. So for that we have to select the time history ground motions which are in the range of same properties in the in which the response spectrums are similar, more or less similar pattern with the target response spectrum. Okay, so the scaling, the selecting the ground motions for specific site conditions is very tedious and it's a very precise job. So we should be very careful while selecting the ground motions for doing nonlinear time history analysis or linear time history analysis. Okay, so by this way we can convert, we can upload, select and scale the time histogram motions and to be applied in the analysis. And if we see the convert to user define, we will see the match time history which we can modify. We can show the time history here with the modify a show button. Okay, yeah, we see the scale time histogram motions. So this scale time histogram motions should be applied in the form of load case in the analysis. Okay, so for this time history we can go to click two option and view the response spectrum. Okay, the response spectrum of that time strip for different damping ratio. Suppose we are using the damping ratio of 0.05 with the pink color. We can see here the damping ratio. We can add or delete the damping ratio from here. Okay, this one is the original earthquake, this one is the massed earthquake, and if we delete all these one and keep only 5% damping, okay, we see the damping for massed and original ground motions. Okay, for original ground motions, the spectral acceleration is in the form of 0.486 g, but in the massed it is 0. It is between 0.83 and 0.93, which is almost double. Okay, so we see the end of here also there are different options. Okay, let me click OK for now. So by this way, the time history ground motions can be scaled in ETABS. Similar procedure can be done in SAT 2000 as well. So today I will stop this, and in the next video we will see how to download the ground motion data from the pure NGA ground motion database. Till then, keep watching my videos. Don't forget to like, share, comment, and subscribe my YouTube channel. Thank you.